So question 10 is everybody have problem with, right? Alejandro, did you figure out question 10? Okay. All right. So yesterday we talked about optimization. The first step is you must draw the picture. If you draw the picture, it doesn't have to be pretty. You just draw the picture. Second, you assign a variable based on the question. So in this case, that we have a question says, we have a question. We're gonna go back look at a question. We did question 7. We says a manufacturer want to design a open box, have a square base, and the surface area of 108 square inches, where dimension will produce the maximum value. Now, so this is a perfect example of the box. See, if you look on the bottom, I just found this on my table. So it has a square base. So this is the type of box that you're thinking of, square base, and then this is the height. Now, it's not the same size as this one, but I did label this is X, and this is X, and this is H, 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 H. So this is probably the best way to illustrate that there's a square base rectangular prism. So this height could be at any height. Now this box, you need to fit a ping pong ball in there, so it has to be longer length. Now, would it be better to have this box extended this way? That's optimization, right? That's optimization that you can box it like, instead the longer one, I can take it like half and put it right next to it. Is that gonna save more material of the box, or things like that? You gotta consider like what is the best case form. So this case says want to design an open box, have a square base. So the keyword is open box, square base, and the surface area 108. What dimension produce the maximum value? So what you're gonna do is we're gonna look at the questions here. So we assign a variable. So we have a open top box like this. So we're gonna assign this to X, this X, this H. Now the hardest part is to visualize this box. Like a lot of you guys don't know how to visualize the box. A lot of think about, it's just phi xh. No, it's not phi xh. The bottom base is x squared. The lateral is xh. So the volume is length, width times height. So it'd be x squared h, and the surface area is x squared plus 4xh equal to 108. Because there's a bottom base is x squared and the lateral side is 4x squared, 4xh. Now, if you have this, you want to find a relationship by trying to optimize. So your equation is going to be try to optimize the things that you're trying to do. For example, I think the first question that Astrid did yesterday, that she have a confusing because she says, well, what am I trying to optimize? So she cannot figure out. But what you're trying to optimize is between two numbers. So product of two numbers. That's why you try to optimize. So P equal to X times Y. So that's, you try to optimize the P, which is a product. Okay, and that's what she did yesterday, and she kind of confused, and at first she using the same equation, same primary equation, same secondary equation, and she plugged in, she got a 0, and she said, well, I don't know what's going on there. But we had to address that. We trying to optimize, in this case, is the value. So if I have a volume equal to x squared h, on the exam, I'm looking for this. What's your primary? Write down your primary equation and write down your secondary equation. The secondary equation is used for reduce a variable. Used for reduce a variable. Yesterday, you see all the questions go through a similar process. It's just like kind of like home problem on related rate, except in related rate is taken due to respect to t.
No. Yeah. Yeah, she is.
Thank you.
Thank you. I'll let her know. She wants to know if Nicole can go to the guidance, Miss Brignac.
Miss who?
Brignac, I barely know how to pronounce her name, so it's Christine.
Oh, it's like I was.
Yeah.
What did she say?
She said to ask you if you can go.
No. You can go ahead in the class.
Alright.
Unless it's something important that you know of. Don't worry about it. Okay, so I hear, because I'm gonna go over the other question first. So then I have x squared plus 4xh. Now I hear you have two options. You can solve for either x or h. Now it's much better to solve h because x is not possible to solve. So I'm moving everything to the other side. I got h is equal to this. This to use to reduce the variables. Okay, this is reduce the variable. So I'm gonna plug this in to the first equation because that way, instead of x squared h, I have everything in terms of x. So what you do is you have this part, you plug in the h, and then you distribute it, and you simplify, you split, you take a derivative. So you distribute this inside, and then you split, and you get 27x minus x cubed over 4. And then you take a derivative, because you take a derivative, it's going to give you a maximum mn. And then you go ahead and solve it. X is equal to 6. How do I know 6 is optimized? Well, we don't know what a 6 is optimized until we take a second derivative. If you take a second derivative, it's a b double prime. I'm going to plug in 6 into here. It's -9. It's concave down. So concave down, draw it concave down like this. That has to be a maximum. Does that make sense? Yes. Yes, sometimes you're gonna have to figure out when is it. Now, if you set up your primary and secondary, you will get half the credit already. So you can get 50% of the test, just set up the equation. So go in and set up all the equation, do the math on all the things that you can do, and then guess what? When you find multiple critical points, you have to test each one. See, are they maximized and minimized? Is that okay? Okay. So this is a question 8 yesterday. But we also did the 4 pig pen question, which is the one that everybody struggled, but I'll just show you how to set up. So this is a river. This is a natural border. Now 4 pig pen next to each other. So it's gonna be 1, 2, 3, 4. This is a y, 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 x, 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 x. I feel like this is the easiest way to set up. And you can set up as a primary is what? Well, primary, we're trying to find out is try to optimize the area of the pig pen. Let's go back and look at the questions. So the question says, 4 pen will be built side by side along the river using 150 feet of fence. So it has to be along the river. So some people, Nelly, on 7th period, trying to debate with me, says that's her pig pen. And I spent, again, I spent a lot of time to argue about pig pen questions. A lot of time, like she says, I built a pig pen like this. And I said, no, you're gonna use more material that way. Also, besides the question says along the river. So this too is not next to a river. So we have, we have figured out that's not the right way. So primary, you're trying to optimize the area of the pig pen. So which is area is equal to, in this case, it's just base times height. So it'd be 4x times y. Natalia, does that make sense? And your 150 feet is just gonna be, well, it depends. Everything add together. It's not times each other, but it's adding. So this is pretty much like this, which is also known as 5y plus 4x is equal to 150. Now you can do the rest of the part of the math. Okay, now you can do reciprocal now. So that's what happened yesterday. So I did a video on this so that way you can still go back and understand. Ignacio, do you understand? Okay, so let's go back to question 10. Question 10 is different. So I don't know if I can do this. Don't think I can do that. Oh, I cannot do that. So a tank with a rectangular base. So the question is not a square base this time, it's a rectangular base, and the rectangular side open on top. So this is not the actual tank that you're driving to the wall. Okay. Trust me, I have some student on AP exam, they thought it was an actual tank. And you're like, no. So she spent half the time thinking about that was the actual tank that she's gonna go fight the wall. So a tank with a rectangular base with rectangular side is open on top is constructed that its width is a 4 meter and the volume is 36 cubic meter. If a building of a tank costs $10 for the base, $5 for the side, what is the cost of this expensive tank? So here's my question: what we trying to optimize? No, the minimize the cost. It's not the surface area because the bottom base of the tank is more expensive because the bottom had to withhold all the pressure. So bottom tank has to be very strong. Now the side panel is going to be a little bit cheaper. If you ever know anything about fish tank, this is what happened. So we're going to write down these questions here. We're going to say, okay, well, we're going to see we can figure out what happened. So we're gonna have a tank. We draw out a tank here, right? We draw out a tank, and we say the base. So the volume is gonna be exactly 36. Okay, and the width is 4. Is that okay? A tank or rectangular base, and the volume has to be 36 cubic meter. And then you say, okay, well, that's good. We figure out how this works. The base the base cost is $10. So that's $10. And the lateral cost is $5. So first of all, let's figure out the surface area. So surface area in this case is equal to, well, width is 4, and we don't have length, and we don't have height. Is that okay? So surface area is 4L. Is that okay? On the bottom. So this is the base. Is that okay? Am I going too fast? How about the side? Plus what? How many H? 4HL? 2 times. There's a front and back, right? So there is a front side is a 4H, but there's a back side is also 4H. Does that make sense? So they are 2 times 4H. Is that okay? And then there is a side. This side is HL, but they are 2 sides. They are equal sides. Well, hopefully. Otherwise, our tank is going to be pretty interesting. 2HL. But the thing is, what Joshua is saying is we're not trying to optimize the surface area. We're trying to optimize the what? The cost. But the cost is different, depends on which panel we're talking about. So this is the lateral, and this is the lateral. Lateral means the side of the box. Now the cost is going to be different. So we're going to build a cost equation. The cost equation is, well, the base is going to cost $10. So it'll be $10 times 4L. Does that make sense? Am I going too fast? Plus, well, the lateral is going to be what? $5. So this is a 5. So I'm gonna use this is a different color so that way you can see it. This is gonna be $10, right? And this is gonna be $5, and this is gonna be $5. Is that okay? And this one is gonna be AH, and this one is gonna be 2HL. Am I going too fast? So that cost is equal to 40L. Is that okay? Plus 40H. Is that okay? And plus 10HO. Is that okay? So far, this is the final primary. Am I going too fast? Now, what is the secondary? What is the secondary? Volume is 36 is equal to 4 times HL. Is that okay? So 9 equal to HL. Is that okay? Yeah, primary we're trying to optimize, but this is a secondary. So let me erase all this part. So is that okay for so far? 9 equal to HO. Now, can I solve for reduce a variable? Which one I want to reduce doesn't really matter. So 9 equal to HL. Is that okay? So what I'm gonna do is I'm gonna go in and I'm gonna reduce the variable. So the cost equation, so which one I want to keep? So I'm gonna say it's plus 10. L is gonna be H times 9 over H. Is that okay? I'm just doing it at the end. L is gonna replace 9 over H, right? And that's plus, this H is gonna cancel out. This is a 40 H, and this is a 40 L. L is gonna be 9 over H. So the cost is equal to 360 over H plus 40H plus 90. Now I'm going to talk about cost derivative. So it'll be 360H to the negative 1. So that will be negative 360 H to the square. Is that okay? Plus 40. Because 90 is going to go to 0. Am I going too fast? And then this is equal to 0. So it'd be negative 360 over H squared plus 40 equal to 0. I'm moving to the other side. So 40 equal to 360 over H squared. Multiply both sides by H squared equal to 360. h squared is equal to, is it 9? Then h is equal to 3. And once you figure out 3, you can plug into the secondary. So 9 over 3 equal to L. L is equal to 3. So be 3 by 3 by 4. Is that okay? And that was the final box. Am I going too fast? Is this on the test? Yes. Yes?
Because you have to find volume. To be primary find volume and find your cost.
What are we trying to optimize? Hold on a second. I think it's dimension. I'm not sure. What other dimension? And what's least cost? So you want to figure out the cost. So you want to plug it into this equations here. I don't know what's the least cost somebody come up with.
I got 330.
330. So it'll be 330. But this is on the test? Yes. Because this is the actual things that you're gonna be in the real business. This is what you're gonna be end up doing. You're trying to reduce the cost of something. Funny things, I actually had to do this in like actual business. I used to be a purchase manager in a purchase company. We had to figure out a lot of stuff like that. Just part of the business. Any question about this part? Is this question on the test? Yes. Is the first day we doing the cut off 4 corners on the test? Yes. Is the fence question is on the test? Yes. And I will not use a river as a natural border this time. You learn to be smarter. Yes.
Sorry, could you go
Let me see. Let me.
That's just for the 4 corners ones.
Yeah. I got up to the equation, but then I don't know.
So it's 3 foot wide. It's square piece of cardboard. So yeah, so this is what Bennett tried to do. And I tried to figure out it doesn't work. So this is 3 and 3. This is 3 by 3, right? You had to cut off each corner, and the corner we cut off is gonna call it the X. So this is on the test. Because you cut off here, then if you fold it upwards, then it's gonna give you the volume. So volume is equal to the X becomes the height, right? Is that okay? The width is gonna be 3 minus 2x, and then 3 minus 2x. By the way, there was a physical domain in this case. The physical domain is x has to be less than 3 over 2, because you cannot cut more than 3 over 2. And then you're gonna multiply together, take a derivative, you find out what is it. I'm gonna finish this problem because you should be able to finish that. But this is your primary. And you don't need a secondary. Secondary is actually 3 minus 2x, but no big deal. It's like width equal to 3 minus 2x, length equal to 3 minus 2x. That's your secondary. So if I really want to say that it's 3 minus 2x, length equals 3 minus 2x. Yes.
What happens for the equations where, like, if you take the second derivative, you just get a constant from it?
That constant could be positive or negative. So for example, let's go back to look at this particular questions here. How do we know this one is maximized or minimized? Because right here we want to minimize the cost, right? Shh. Right here we want to minimize the cost. So what we're gonna do is we're gonna take second derivative of this. What happens if you have second derivative? So c prime equal to negative 360 over h squared plus 40. What is c double prime? H to the third.
No,
It's positive, right?
Yeah.
So if you plug in 3, what will happen? If I have 720 plug in 3s to the cube, is a positive. It's positive, it's concave up, so it's minimum cost. Does that make sense? And that's how you verify something. Yes.
So if for number 5 or 4, if you took the second derivative, you just get a constant number. Like for 5,
It will depend on your constant number, is it positive or negative.
if it's negative, then it would be maximum, and if it's positive, it's a minimum.
If it's negative, it's concave down, it's a maximum.
Yeah.
Yes.
And then that's how you know that it was correct.
Mm-hmm.
Okay. Thank you.
All right, so we're gonna talk about other 2 questions. So today, this one's kind of confusing for some people as well. So we want to find out a minimum distance. Now this one's kind of tricky. So let today, what if I have y equal to 3 minus x squared? Oh no, sorry, 4 minus x squared. 4 minus x squared, that's a function. And you want to find which point on a graph of y equal to 4 minus x squared or closest to 0 comma 2. So again, some of you guys may not know how to graph, but 4 minus x squared is basically x squared upside down, and that 4. And they should intercept at 2, so this graph is going to be like this. Okay, so this point is 0, 2. Like, which point on the graph is going to be the closest to that point, the blue point here? Which point do you think is the closest? Where do you think the point on the graph is closest to the dot there? Yes?
Same number.
Y equal to 2? No. So this case is kind of different. This case, we don't have type of relationship. But what we're trying to optimize here. Good. Is anything called distance formula? Do you guys remember what's distance formula? If you don't know the distance formula, it's actually fairly easy to get. I'm going to show you really quickly. It's actually Pythagorean identity if you really think about it, right? If you have a point right here and you have a point right here, right? And let's just say this is a 1 comma 1 and this is going to be 5 comma, I don't know, 4, something like that. You want to find the distance formula. Well, basically there's a changing of x and there was a changing of y, right? And this is the distance, would you say? So distance square is equal to changing of x square plus changing of y square. Are you following me? It's Pythagorean identity. So d is equal to square root of changing of x square plus changing of y square. Now, that becomes x2 minus x1 square plus y2 minus y1 square It's not memorization, it's understanding. So you're like, I don't remember distance formula, but this actually is not hard to memorize. It's Pythagorean identity. Now we obviously have a point. So distance is equal to, oops. Distance is equal to, well, we are comparing the x of this function. So this is y equal to 4 minus x squared. So we're gonna say x, well, compared to this point is 0, comma 2. So it'll be x minus 0 squared. Does that make sense? Because the difference between the function x and the coordinate is gonna be x minus 0 squared. Plus the function y minus 2 squared. But what is y? Because we have x and y in this case, we want it both to be uniform. But what is y in this case?
4 minus x squared.
4 minus x squared, thank you. So be 4 minus x squared minus 2 squared.
Equation.
Yeah, the equation. That was the y. The x is just the x. Y is the output, which is the function. So here it's going to be x squared plus 2 minus x squared squared. Which, as we know, that we can expand that. So be x squared plus 4 minus 4x squared plus x to the 4th. Is that okay? So be x to the 4th minus 3x squared plus 4. So far, do you guys understand? Now, here's a tricky part. You can take a derivative of this, and you're going to get same result. But they require a chain rule. But what I'm going to do is actually, I'm not going to take a derivative of this. It's still going to give me the same result, but because we square root anyway, it doesn't matter. So this is always going to cause confusion. Now, you can do whatever heck you want, but I'm going to tell you, you can just take a derivative of the inside. Because at the end, you're going to square root. So you optimize inside, you square root is just a final extension of that. So that doesn't really matter. Longer as inside is optimized, then outside is same thing. Now, if you do chain rule, you're going to get same exact answer, by the way. So in this case, I'm going to take a derivative of this x to the 4th minus 3x squared plus 4. So it'll be 4x to the 3rd minus 6x is equal to 0. If you factor out a 2x, I'm going to get what? 2x squared minus 3 equal to 0. So x equal to 0, x equal to plus minus, I think it's root 3 over 2. But this is not an answer, because one of them is right here. So one of them is right here to here. One of them is like somewhere around 3 over 2 is 1.5. Square root 1.5 is less than, is somewhere around here. Now, which one's less distance, right? We don't know which one's less distance. Is the one on the top or the one on the side? So this is why second derivative matter, because second derivative matter here. What we're going to do is we're going to take second derivative here. So second derivative is going to give you a 12x squared minus 6. So this is a distance double prime, and distance double prime. If you put a 0, it's going to be 12 times 0 squared minus 6. That's equal to negative 6. That's concave down. That's relative maximum. It's actually not correct. So it's not this one. Is that okay? Now I'm going to plug in the root 3 over 2. So it'll be 12 times root 3 over 2 squared minus 6. Well, that's equal to d double prime of root 3 over 2 That's equal to 12 times 3 over 2 minus 6. This is 6. 18 minus 6 is 12. So 12 is concave up, and that's minimum distance. So the minimum distance occurred at square root of 5, 3 over 2 to 5 over 2, and the negative 3 over 2, 5 over 2. And that's if you plug in the original function. Now, I think the biggest problem of people think is, what if I can take a derivative over here with a radical? You can take a derivative radical, you're going to get the same thing because the chain rule is still inside anyway. The outside is on denominator, so it doesn't really matter. You can do it that way if you want. You can try it. But I'm going to tell you, is you trying to square root at the end, so it doesn't really matter if you take a derivative of the square root or not. A lot of people confused about that, and even write down, you don't say so. But you're trying to optimize the distance is the square root at the end. It doesn't happen at the very beginning. So you try to optimize the inside material first, so the square root happened afterward. So if you optimize square root 4 and square root 2, 4 is going to be bigger. So this is one question. What time we get off? Okay. So the other question I'm going to talk about is this. Before you get off, I'm going to say there's one more question on the test that you have to worry about is, what's the biggest box you can build inside this? So what's the biggest box? The same equation like this, right? What is the biggest rectangle you can build? If I want to build a biggest rectangle, I can build like this size or this size, right? How do I know which one? Well, the is actually just figure out, well, this size x, this size x, and this size y. So area is actually 2xy. And the area is equal to 2x times y, which is in this case 4 minus x squared. And then you can optimize that way because the problem is each side has an x, right? You're trying to build the biggest rectangle. So you're going to have some homework question about this particular one. This will be on the test as well. And the distance will be on the test. All those box and pig pens will be on the test. And you might get some surprises. They're fun surprises.
Oh, my birthday is over. Why do we need surprises?
Because I missed a year.
Want to see on my back?